Beneath every struggling garden in America sits a graveyard, not of plants, of organisms, billions of bacteria, fungi, protozoa, and nematodes that once made soil fertile, that once converted dead leaves into living nutrients, that once fed roots on demand and suppressed disease without a single chemical input, gone. Killed by decades of synthetic fertilizer applications, repeated tilling, and commercial potting mixes sterilized at temperatures designed to destroy every living thing inside them. The soil looks like soil. It holds water. It surrounds roots. But biologically, it is a corpse. And no amount of nitrogen, phosphorus, or potassium poured on top of a corpse will make it breathe again. Meanwhile, a brew made from rice, milk, and sugar, costing less than $1 and requiring less than 10 minutes of preparation, has been scientifically documented to resurrect the microbial populations that make soil function. The garden products industry sells you chemistry to treat the symptoms. This brew rebuilds the biology that eliminates the cause. The record opens in Okinawa, Japan, in the early 1980s. A soil scientist named Dr. Teruo Higa at the University of the Ryukyus was studying why certain traditional farming practices consistently outperformed modern synthetic systems in long-term soil health. What he discovered was not a single organism, but a community. Lactic acid bacteria, photosynthetic bacteria, yeasts, and actinomycetes, working together in fermented cultures, could revive biologically depleted soils that synthetic fertilizers had failed to recover. He called the concept effective microorganisms. Within a decade, the practice had spread across Asia, the Pacific, Latin America, and Africa. Within 2 decades, the University of Hawaii's College of Tropical Agriculture and Human Resources had published peer-reviewed extension guides documenting the exact method for culturing these organisms at home from rice rinse water and milk. The recipe was never a secret. It was published by a major American university. It simply did not sell a product. A 2024 review published on ResearchGate confirmed that effective microorganism applications improve soil health, nutrient cycling, and crop productivity across multiple environments and crop types. A 2023 paper published by the College of Tropical Agriculture and Human Resources identified the specific bacterial species present in fermented rice, water, and milk cultures, confirming the presence of nitrogen-fixing bacteria, phosphorus-solubilizing bacteria, and lactic acid bacteria in concentrations sufficient to function as a biological soil inoculant. A 2019 College of Tropical Agriculture and Human Resources publication on Korean natural farming documented the complete system for cultivating indigenous microorganisms from rice water, confirming that the method enhances soil microbial activity and fertility in nutrient-depleted conditions. The knowledge was never buried. It was published in plain English by a public university. It simply costs $1 instead of $50. Here is the brew, the science behind it, and the method that makes dead soil breathe again. The science. Why your soil is dead, and what died. Charles Darwin spent the final years of his life studying the organisms that build soil. His 1881 masterwork, The Formation of Vegetable Mold Through the Action of Worms, documented what modern soil science has since confirmed at the microbial level. Soil is not a mineral substrate. It is a living, digestive system. Earthworms, bacteria, fungi, and protozoa consume organic matter, decompose it, and convert it into forms that plant roots can absorb. When those organisms die, the digestive system stops functioning. The minerals remain in the soil, but nothing is breaking them down, nothing is delivering them to roots, and nothing is suppressing the pathogenic organisms that thrive in biologically empty ground. Commercial potting mixes are sterilized before sale. UC Davis documented the heat treatment process used by commercial nurseries and potting soil manufacturers, confirming that temperatures sufficient to kill pathogens also destroy the beneficial microbes that make soil biologically active. When you fill a raised bed with store-bought potting mix, you are planting into sterile ground. Synthetic fertilizers applied to sterile ground bypass biology entirely, delivering soluble nutrients directly to roots in a chemical spike that lasts days before leaching away. The soil never develops the microbial population that would make it self-sustaining. You buy more fertilizer. The soil stays dead. The cycle was designed. The Brew, how to make it. The method comes directly from the University of Hawaii CTAHR extension publications on Korean natural farming. Adapted for home garden use. It has 2 stages and takes 6 to 10 days total. Stage 1. Fermented rice water. Rinse 1 cup of uncooked rice in 2 cups of clean water. Agitate the rice until the water turns cloudy. Strain the rice out and save the cloudy water in a clean glass jar, filled roughly 2/3 full. Cover the jar with a breathable cloth, a paper towel, or cheesecloth secured with a rubber band, and place it at room temperature out of direct sunlight for 3 to 5 days. The starches leached from the rice grain surfaces feed naturally occurring lactic acid bacteria that are present in the air and on the rice itself. Over 3 to 5 days, these bacteria multiply explosively. The liquid will develop a mildly sour, slightly fermented smell. This becomes your lactic acid bacteria starter culture. Stage 2. Milk multiplication. Take the fermented rice water from stage 1 and add it to fresh milk at a ratio of 1 part rice water to 10 parts milk. Whole milk works best. The proteins and sugars in the milk become food for the lactic acid bacteria, which multiply far more aggressively in the milk medium than they did in the rice water alone. Cover loosely and leave at room temperature for 5 to 7 days. The milk will separate into 2 distinct layers. A solid white curd will float on top. Below it, a clear to yellowish liquid. The whey will collect at the bottom. That whey is your finished product. It is a concentrated liquid culture of lactic acid bacteria at populations dense enough to function as a biological soil inoculant. Strain off the curd. The curd can go into your compost pile or be fed to chickens. The whey is your brew. Store it in a sealed glass jar in the refrigerator, where it remains viable for several months. For optional mineral supplementation, add 1 tablespoon of clean hardwood ash per quart of finished whey before application. The University of New Hampshire Extension published a detailed guide on using wood ash as an agricultural soil amendment, confirming that ash provides potassium, calcium, magnesium, and over a dozen trace minerals in forms that are immediately available in liquid solution. The ash also raises the pH of the slightly acidic whey toward neutral, which benefits most vegetable crops. The application. How to use it. Dilute the finished whey at a ratio of 1 to 20 with clean water. 1 cup of whey concentrate to 20 cups of water. This dilution ratio is critical. The concentrated lactic acid bacteria culture is potent enough to shift soil pH if applied undiluted, and the goal is inoculation, not sterilization. Apply the diluted brew as a soil drench directly to the root zone of plants, or across empty beds you are preparing for planting. Use 1 to 2 cups of diluted solution per square foot of garden bed. Apply once per week for the first 4 weeks, then taper to once every 2 weeks for maintenance through the growing season. The lactic acid bacteria in the brew perform 3 documented functions in the soil. First, they accelerate the decomposition of organic matter by producing enzymes that break down cellulose, lignin, and proteins in compost, mulch, and crop residues, converting them into plant-available nutrients faster than unassisted decomposition. Second, they suppress pathogenic fungi and bacteria through competitive exclusion and through the production of lactic acid, which lowers the pH of the microenvironment around the root zone to levels that favor beneficial organisms and inhibit many common soil-borne pathogens, including Fusarium, Pythium, and Rhizoctonia. Third, they stimulate earthworm activity. Earthworms feed on the bacterial and fungal populations that colonize decomposing organic matter. A surge in lactic acid bacteria creates a surge in the food supply that earthworms consume. Within weeks of consistent application, earthworm populations in treated beds increase measurably compared to untreated controls. The CTAHR publication. SA23 identified the specific bacterial genera present in fermented rice, water, and milk cultures, confirming Lactobacillus as the dominant genus alongside populations of Bacillus and other beneficial soil bacteria. The SA19 publication documented the complete Korean natural farming indigenous microorganism system and confirmed that reintroducing cultured microorganisms into nutrient-depleted soil enhances microbial activity, improves soil fertility markers, and increases plant growth across multiple Hawaiian farm sites. The warning: what happens when you remove chemicals without replacing biology? In 2021, Sri Lanka banned synthetic chemical fertilizers overnight in a national push toward organic agriculture. Within months, rice yields dropped by 20%. Tea production collapsed. Vegetable prices doubled. The government reversed the ban within 7 months. A 2025 peer-reviewed study published in the journal Food Security analyzed the failure and confirmed that the problem was not the removal of synthetic inputs. The problem was that no biological replacement was provided. The soil had been managed with chemicals for decades. The microbial populations were gone. When the chemicals were removed, there was nothing left to cycle nutrients. The soil was biologically dead, and removing the chemical life support without rebuilding biology first caused the system to collapse. The lesson for home gardeners is direct. If you have been using synthetic fertilizers for years, your soil biology is likely depleted. You cannot simply stop fertilizing and expect the soil to recover on its own. You have to rebuild the population first. This brew does exactly that. It reintroduces the lactic acid bacteria, the decomposition enzymes, and the microbial food web that makes soil self-sustaining. Once the biology is established, the soil begins cycling its own nutrients from organic matter, and the need for purchased inputs drops toward zero over successive seasons. But it survived. The knowledge of microbial soil revival never disappeared into laboratory archives or agricultural industry pipelines. While the synthetic fertilizer system was consolidating into a $230 billion global machine, Korean natural farming practitioners preserved the rice water and milk fermentation method through 4 decades of continuous practice across Asia and the Pacific. Dr. Teruo Higa published his foundational work on effective microorganisms in the 1980s. The University of Hawaii CTAHR published peer-reviewed extension guides documenting the exact method between 2013 and 2023. Korean natural farming networks trained thousands of farmers across Hawaii, the Philippines, Thailand, and Latin America using the same fermented cultures described in this recipe. None of them needed a bag of synthetic fertilizer. All of them needed soil that functioned on its own terms. Darwin told us in 1881 that the organisms in the soil are the engine of all terrestrial fertility. Higa confirmed in 1989 that those organisms can be deliberately cultured and reintroduced to depleted ground. The University of Hawaii published the method in English, for free, with step-by-step instructions and identified bacterial species. The Sri Lanka crisis of 2021 proved what happens when you ignore the biology. Today, that knowledge is accelerating. Not because the industry promoted it, but because gardeners who poured synthetic fertilizer onto dead soil for years and watched nothing improve started asking why a $1 jar of rice water and milk could wake up what a $50 bag of chemicals never touched. The silence around microbial soil revival is breaking. You can revive what they declared dead. Start tonight. Rinse a cup of rice. Save the cloudy water. Cover it with a cloth. In 3 days, you will have a living culture. In 10 days, you will have a concentrated biological inoculant that can resurrect the soil in every bed in your garden. The total cost is less than $1. The biology it rebuilds is priceless. The garden products industry profits from the assumption that dead soil requires purchased inputs every season to produce food. This $1 brew begins with the opposite truth, that soil was never meant to be dead, that the organisms that make it alive can be cultured in a kitchen jar, and that the only thing standing between a dead garden and a living one is a handful of rice and a cup of milk. The knowledge was never lost. It was waiting in the rice pot, in the milk jug, in the extension publications, in the hands of farmers who never needed a chemistry degree to grow food in living soil. If this seed was finally freed for you, subscribe to Hank's gardening journey and hit the bell. Every like and every share helps break the silence. The next seed breaks free soon.